There is one complication that we can run into when we're solving equations that involve radicals. And that's the same complication that can always come up when we're solving an equation that involves some interesting function. And it has to do with any limited range of the function that appears in the equation. Now, if n is an odd number, the range of the nth root is all real numbers, so there's no problem. However, if n is an even number, the range of an even root is the numbers that are greater than or equal to 0. Right? When we take the even root, we choose the positive even root. So the equation nth root of x equals c has no solution if n is an even number and c is a negative number. So just to see a few simple examples, the third root of 5, totally fine. Right? This is positive, this is odd. We can write that as x is 5 to the third, x is 125. Here we have the fourth root of x is 2. That's fine. 2 is positive. 4 is even. We can rewrite this as x is 2 to the fourth power. In other words, x is 16. Fifth root of x is negative 3. Well, this is negative, but our index is odd. So this is fine. X is negative 3 to the fifth power. In other words, x is negative 243. That's fine. However, in this last example, we have a negative number on the right. We have an even root on the left. The square root is always a positive number or 0. It can never be negative 7. So this has no solution. So odd roots can be any number. Even roots can never be negative. As usual, the point at which we have to check for this is after we finish isolating the radical. So here we have a couple of radical equations in which our radical is not alone on one side of the equation. So the point at which we would have to stop and say, okay, this has no solution because it says even root is a negative number, is once the radical is by itself. So in this example, here's my radical that I want to isolate. I'll start by subtracting 5 on both sides. So root 3x minus 1, or negative 2 times that, is negative 3 minus 5 is negative 8. And then I'll divide both sides by negative 2. And I've got the square root, 3x minus 1, is positive 4. This is positive. This is an even root. We're okay. We can rewrite this as 3x minus 1 is 4 to the second power. In other words, 3x minus 1 is 16. Okay, now we just need to solve for x, right? Add 1 to both sides. 3x is 17. Divide both sides by 3. X is 17 thirds. To check that that's correct, we'll say, well, we've got negative 2 times the square root of 3 times 17 thirds minus 1, all plus 5. Working out that arithmetic inside the square root, we'll have negative 2 times the square root of 16, all plus 5. So negative 2 times 4 plus 5. That's negative 8 plus 5 really is negative 3. So that worked. Okay, over here we have 3 times the square root 4x plus 1 plus 7 equals 4. We'll start by subtracting 7 on both sides. So we'll have 3 times the square root 4x plus 1 is negative 3. We'll divide both sides by 3, and we'll have the square root of 4x plus 1 is negative 1. But now this is negative, and this is an even root. Even roots can never work out to a negative number, so we know that this has no solution. Once we know that there's no solution, we stop doing algebra. So this equation just has no solution.